Right now, in this Haas tip of the day, we are going to manually set the tools on this Haas lathe. 2 buttons, some jogging, some measuring, some verifications, a tip direction, and the size of the radius on our tools. That is it, and your Haas lathe will be all ready to cut apart. This is really good stuff. Now we've got 4 or 5 different kinds of tools loaded up, and we're going to manually set those now. When we load up a tool, the machine doesn't know where it's at until we tell it. So every time we put a tool into this machine, it might end up in a slightly different position, and we're going to have to reset our tool offsets. Now, a tool offset is just a distance, how far that tool is out of line. And on a lathe, the line that we're talking about is our spindle center line. Rule number 1, and nothing we talk about is going to make sense unless we mention this. This is a lathe, and on a lathe, all of our X values are in diameter. So we can forget about the number line that we were taught in school. We were shown that this is the X and this is the Y, typically in our math classes in 6th grade. But on a lathe, this is our Z axis. So we've got our Z minus heading towards the spindle, Z plus heading away from the spindle. Then we've got our plus and minus X values. But even this is incomplete. This is not an X value, it's an X diameter value on a lathe. Here, this will make more sense. We'll show you what's going on the part that's in our lathe now. This stock is 3 inches in diameter, 76.2 millimeters. And while this point here is just 1.5 inches, 38.1 millimeters from our center line, we don't call it X 1.5 or X 38.1. We call it X 3.0 or X 76.2. Because on lathes, our X values are in diameter. So our X0 is our spindle center line, and our Z0 is typically the face of our part. This is how parts are programmed, and this is how we're going to set them up. Now keep that in mind as we jog our turret to a safe location and command tool 2 into position. Okay, enough theory. Let's go ahead and set that tool offset X value. I'm going to start the spindle at 250 RPMs by entering 250 and pressing the spindle forward key. Now we can run the spindle faster for smaller parts or when turning aluminum, and we will want to turn it slower if running a larger part or when cutting harder materials. We will use the hand wheel on 0.001 increment until we make light contact with the outside of our stock. We'll hand jog across the material in the Z-axis until it is cleaned up completely. Okay, this is the important part. We need to jog straight away using only the Z-axis in the Z positive direction. And we're going to go far enough to give ourselves some clearance. We can then press reset and stop the spindle. All right, so we skimmed the part, being sure to move only in the Z-axis. Now we can navigate and go to our tool offset page. Now we'll want to highlight the tool offset that we're going to set. In this case, we're using tool 2, so we're going to set offset 2. If you ended up on the work offset page, you can just press the offset button again on a classic control, or press the F4 key if you're on an NGC lathe to toggle back over to our tool offset page. With the correct tool offset highlighted, we press the X diameter measure key, and up comes a pop-up asking us to enter our current X diameter. Now this is why we jogged so far away from the part a moment ago, to give us room to reach in with a set of micrometers and measure our newly turned diameter. Now we measured 2.9705 inches, 75.45 millimeters. That is the X diameter position that our tool is currently at, and we know this because we just measured it. Now we'll go ahead and enter that value, and the control does the rest for us. The tool offset that is calculated is the exact machine position required to put the tip of our tool directly on our part center line, X0. With the X set, we're going to do something very similar to set the Z. We'll start up our spindle and carefully jog over to our part and lightly skim the face, making sure to move away only in the X axis. We can use the hand wheel for this, or we can just press and hold one of the axis selection buttons to automatically jog in that axis. Make sure you're on a slow increment. And we could have done this earlier as we skimmed the outside diameter of our part as well. So we'll press the reset button, we'll stop our spindle, and with the proper tool offset highlighted, we can press the Z face measure button. The Z tool offset calculated is the exact machine position needed to put the tip of our tool right on our Z0 face. Now, technically, our manually set tool offset values are just the distance from our machine home position to our spindle center line and the part face where we touched off for any particular tool. Now, if you're on a TL machine, a tool room lathe, that setup is going to look a little bit different. The tool is going to be coming at the part from a different direction. On a TL, the X positive direction is towards the operator. Now, to avoid any confusion, jog around a bit first until you get the feel for the axis directions. TL lathes also have an electronic hand wheel option with automatic jog buttons and knobs that speed up and slow down the feed rates for us, which makes that kind of manual turning, like we did just now, really effortless. Before we move over to our work offset page and write a little bit of code to check our setup so far, we have two more essential columns on our tool offset page that need to be set. Now, certain operations and tool compensations need to know which direction our tool is facing in order to cut the part properly. And this is called our tip direction. This is an OD turning tool pointing in the X minus Z minus direction. So we'll select tip direction 3. Now, if you are running a TL lathe, we would still choose a tip direction of 3 for this tool because it is still pointing in the X negative, Z negative direction. Lastly, we need to fill out our tool radius geometry. That's the size of the radius on the tip of our insert. And we can find this information on the product page for any inserts that we buy. And it's also right in the part number written on the box of the insert itself. Now, these are our inch inserts, ANSI, ANSI inserts, and they are CNMG 432s. That last number, the number 2, stands for 2/64ths of an inch, or 0.031 31,000ths of an inch. So we're going to enter 31 thou as our tool radius geometry. If this was an ISO insert, a metric insert, the number might look like CNMG 120408, where that last number, the 08, means that the tool nose radius is 0.8 millimeters. So if we were in metric mode, we would have entered 0.8. Now, there is a lot that can be said about tool nose radius compensations, too much. So we're going to leave that for another advanced lathe programming video. I will say, however, that if you ever run a part that has lots of steps in it, lots of corner chamfers, and those chamfers have disappeared completely, leaving you with sharp edges, there's a good chance you probably have an incorrect value right there on your radius geometry column. So it does make a difference for your compensations. Again, we'll talk about that in a future video, but we will move that up on the list. Those are the basics of tool offsets. Now let's go ahead and toggle over to our work offsets for a minute. Now, a work offset is just a unique coordinate system used for a certain operation. We might use G54 for the first op on a part and G55 for the second op. Now, a tool offset is just an offset being used for one particular tool at a certain time. A work offset is more global. It's going to affect all of your tools at once, and it's just a shift from where those tools were originally touched off. For now, we want to make sure that both our X and our Z G54 work offset are set to 0. We got to set them to 0 for now. And we're going to look at this again after we've touched off the rest of our tools. Our next tool is a drill. Now, drills, taps, reams are on-center tools. And the center of the tool and the tool's holder need to be on center, aligned with the spindle center line. To set the Z, we will load the drill back up and jog it up to the exact same Z face that we had turned with our OD tool earlier. That Z face will serve as the touch-off location for all of our tools in this basic setup. We can use a piece of paper or shim stock to feel for contact as we carefully jog the tool up to the face in the Z. We can use the 0.001 jog increment or 0.0001 for better accuracy. Now, we jog until we feel the paper or the feeler gauge drag, and then press the Z face measure button while highlighting our tool's offset. If you used a shim, you will need to subtract the thickness of the shim from your Z offset to account for it. Now, we just touched off a pretty big drill. It's 32 millimeters in diameter, about 1.25 inches. Now, our drills have no tip radius, so we'll enter 0 for our radius geometry. And the tip direction, we're going to set to a 7 because drills point in the Z- direction. Next on our list is our boring bar. Now, we've been setting up all of our tools in a very specific order. We set up our OD turning tool first because we needed that Z face to set all of our tools against. And next, we have to set up the drill because we need a drilled hole in order to set up our boring bar. We'll go ahead and use our boring bar to skim the inside diameter of our part, making sure that we jog straight away from our part using only the Z-axis when we're done. Now, we're going to leave ourselves enough room to reach into that bore with a measuring tool, a bore gauge. Now, we are at 1.280 inches, 32.512 millimeters in diameter. We will once again highlight the tool that we're going to set and press that X diameter measure button. The tool is currently sitting at 1.280 inches. We know this because we just measured the bore and we have not moved the X at all. So we'll enter that and let the control do all the calculations. To set the Z on this boring bar, we've got to jog the tip of that tool up against our Z face again and press the Z face measure button. Now, the insert on this boring bar has a nose radius of 1, which is 15 thou and 6/10 or 0.4 millimeters. So we're going to go ahead and enter that now on our radius geometry column. And we are approaching the part from the X plus Z minus direction, so we'll be using a tip direction of 2. Other OD tools can be touched off in the same way. You don't always need to skim the part if you have a known diameter to work with. You could touch off with paper and enter the known diameter when the X diameter measure button is pressed. For threading tools, you can choose to set your Z value at the center of the cutting tip or at the edge of the insert. Now, I've gone back and forth on this one. If I am threading clean up against a shoulder, I am definitely going to touch off using the edge of the insert because I don't want to accidentally hit this wall. For standard threads, where there are no clearance issues, I may set my tool on the edge and then adjust my Z for that tool by half of the insert width. Now, this insert is 5 millimeters wide, so I might adjust my Z by 2.5 millimeters, 100 thou, putting the tip of our 60-degree insert on center, which would allow me to program the Z value on my thread with a number that matches the blueprint. Well, that is it until next time. We hope that this video goes a long way in helping you get up and running on your new Haas lathe. Thanks for letting us be a part of your success and for watching this Haas Tip of the Day.